Here we're talking about absolute maximums and minimums and local maximums and minimums. To find an absolute maximum, it says that a function will have an absolute max at an x value of c if the y value at c is bigger than all other y values for all x in the domain of f. So what that's saying is if we have a y value that's bigger than all other y values, and that is the tallest point in the graph, then that's the absolute maximum. Here we've got an absolute minimum at c if the y value at c is smaller than all other y values in the graph. So the smallest point in your graph is called your absolute minimum. For locals, we're looking for y values that are bigger than all other y values, but only near c. So just in a local area. So it's a maximum in that section of the graph. A local minimum would have a minimum, but just in a certain section of the graph. So again, near C instead of the entire graph. Because we're using the word near C, they put this extra restriction that what they mean is it's all x in some open interval containing C. That's a G. Containing C. So what that will say is it's got to be open, and that's telling us it can't be an endpoint. It's got to be some open interval. So let's look at example one. We've got a cosine wave, and they're wanting us to find all maximums and minimums. So if we go through, we see, let's look for maximums first. Here's a maximum, here's a maximum. And it matches our absolute maximum definition, because the y value here at 0 is bigger than all the other y values. This is taller than all the other y values. And then the same thing at 2 pi. This is taller than all the other y values. And since these are equivalent, they're both absolute maximums. So this is an absolute max, and this is an absolute max. They're also local maximums because they are the max. This is the maximum in that section, and this is the maximum in this section. So they're also local. And then I also have then some minimums. I've got a minimum here and a minimum here. These, again, since they're the same, they're both absolute minimums. And they're also local because they're the minimum in that section. Now, because cosine is repetitive and I'm only showing part of the graph, I need to make a rule for my absolute maximums. So I've got absolute and local maximums. And where can we find them? So the first one I see is at 0. And the next one I see is at 2 pi. And so what I see here is if I start at 0 and add 2 pi, I'll get the next maximum. And I can add 2 pi again and add 2 pi again to get the other maximums. So the rule would be starting at 0, we can add 2 pi multiple times, so 2 pi in. And every time we do that, we get a maximum with a y value of 1. So the y value is 1. Let's make a rule for absolute and local minimums. We see our first minimum in my graph at negative pi, so I'm going to start there. And again, if I add 2 pi to negative pi, I get my next minimum. And I can keep adding 2 pi however many times I want to get all the minimums. So negative pi plus 2 pi in. And those y values are negative 1. So that's my answer for example 1. Example 2, we've got a parabola, and we see we don't have any maximums, but we do have a minimum. This is both a local minimum because it is the smallest point in this section of the graph. It's also an absolute minimum because it is the smallest point or the lowest point in the entire graph. So that's at 0, 0. Example 3, there is no maximum because every time we pick a point that might be a maximum, there's another point that is greater than it. There's always another y value that's bigger than it. And if I were to try to make this one my minimum, there's always a point that's smaller than that point. So there are no max and no min. No max and mins. Example 4, let's look for our absolute. So I've got an absolute max, which means the tallest point in the whole graph. And that would be right there. Absolute max at negative 137. Then let's look for our absolute min. The smallest point in the whole graph. That would be down here. The absolute minimum is 3, negative 27. So there is no point smaller than this point, so that is my absolute min. There is no point taller than this point, so that's my absolute max. Then let's look for local maximums and minimums. Remember what it said in the local max and min definition. It has to be an open interval, which means it can't be an endpoint. So even though that's an absolute maximum, this is not considered a local maximum. This point here, 0, 0, this is a local minimum because in this section of the graph, that is the smallest point in that section. So 0, 0 is a local min. Let's go ahead and keep looking for local mins. This is a local minimum because this is the minimum in that section. And it's not an endpoint. So those are my only two minimums that I see. Local maximum. This is a maximum, but it's not local because it's an endpoint. This is a maximum at 1, 5 because it's the tallest point in that section of the graph. And then this would be another maximum, but it's an endpoint, so it doesn't count. So my only local max is 1, 5. In example 5, we've got this weird looking graph. Let's just gonna go through and label what we see. Let's look for absolutes first. My absolute maximum would be the tallest point in the graph. So that is an absolute max at R. Then let's look for absolute minimum. The smallest point in the whole graph, or the lowest point, is at A. So this is my absolute minimum, is at A. Then let's consider where are our locals. So this is an absolute minimum, but not a local because it's an endpoint. Here I've at B. B is a local maximum because it's the tallest point in this section. It's the tallest point, or the biggest y value from A to B, and then it's also from here to here, it's the biggest. So it's the tallest point in this whole section. I've got C. It's an empty point here, so this won't count as a maximum because it's not filled in, it's undefined right there. Then I've got C here. It looks like it could be a maximum, but just to the right of C, all the y values are smaller, so that would meet the definition of a maximum. To the right, everything is smaller than C. But to the left, everything is bigger than C. So C is actually nothing. So none at C. At D, we have a local minimum because the points just to the left and just to the right are bigger than D. So D is a local minimum. R. R we said is the tallest, so it's absolute. It's also local because points just to the left and to the right of R are smaller than R. So R is a local maximum. And S would be a minimum. It's a minimum from the left side because all the points to the left of S are bigger. But we don't know what's happening to the right, and local minimums cannot be endpoints. So there are none here. There are no absolute mins or max on example 5.